Hello, my name is Travis Taylor, and this week I'm not going to be doing DCD Create by Example image database presentation as others are doing. This week I'm going to be going over my master's project. Before I start formally, I'm going to just go over some of the concepts, particularly in the title. So start visualization of programming concepts using augmented reality. I usually go in order. We'll start with augmented reality. If you're not familiar with it, you might be familiar with virtual reality. In virtual reality, your sensor, particularly the site, is replaced to give you an idea of you're in a new location. For example, you might be sitting in a room, but you perceive that you're somewhere else, maybe in a workshop. In augmented reality, you could still perceive that you're in a room, but maybe useful things you could see. For instance, maybe you see different things in the room that other people cannot see. I think that's a good example of the difference between the two. In the visualization, the programming concepts, basically the idea is instead of an int being represented by, the word int and its name and its value, it can be represented in addition to that. Maybe you can see this cube. This is the integer. I can move it. I can manipulate it here. I can put it somewhere where it will be more visible to me, more convenient to me. Basically, you can see it, manipulate, put things into it, see it. Oh, it's changing this way. Just a very visual way of looking at it for those who might be into that. So first, when you create some of the issues, why did you create this? And the problem is, first, your students can have trouble understanding programming, which goes without saying, because you know. If you know, you know, but you can't know when you first start. But for research, there's various reasons that retention or engagement with a program like program or any academic program can be increased or decreased depending on curriculum, how things are presented. Visual learning is one way that can help people learn, particularly for visual learners, people who think more visually than abstractly. And in addition to the idea of visual learning, novelty itself also plays a factor. People like to be interested in what they're doing. So for this reason, I thought that something more easy to understand about representation of the abstract variables that has value, which leads to this project. This is a teaching aid to computer science concepts. The very simple ones, the assignment of variables, initialization, casting, and the integers and arrays, which may seem overly simple, but I countered that with these are some of the ideas that you're going to be using forever. And when you first start, it can be easy to miss. These things can cause you errors, and especially when you first start, you're not gonna have the bug fixing experience. So being able to visualize and understand what's going on in your code, so you can fix it, especially when these simple things are often going to be the cause, barring things such as bad packages or bad syntax, is going to be important. Also of note is this is a proof of concept. I say the point of this is not to recreate all of Java, but in a 3D environment. That's well beyond the scope of this project, just in case that's what you thought that we were doing. First, I want to talk about the tools used and how it's designed. Of note is the Meta 2 in the company SDK. Meta 2 is an augmented reality headset. It's fairly lightweight. It uses a visor so you can see through its plastic or glass, and it projects an image onto it that's reflected. Has fairly high opacity as you're going to see. And it has a software development kit that is compatible with Unity. Unity 3D is used to create the virtual environments. I use to create all the variables and the data values that interact. Unity 3D is a primarily drag and drop based environment, but it does support C#. So using C# is implicit to using Unity 3D, particularly for customization. Unity 3D offers a customization through the C# programs, its own definitions for things like cubes and such, which is useful as opposed to having to figure it yourself, and is accompanying methods such as collision and such, which is all extensively used in this project. So as this proof concept, what's done so far is integer values can be assigned to integers and integers in an array. So you will see your value change in real time. You can visualize where it is in an array. This is that's possible. Also doubles can be cast to integer values. This mostly focuses on integers, but I think the casting and how casting works for doubles is also a point that can be lost. But it's much easier to understand when you can see it. Arrays varying size can be instantiated. We're only going to show one size, but being able to dynamically see what size your arrays at is also good, as opposed to having to keep track of it by looking at what you set it as. And the instantiation and assignment of variables reports to a display. At the moment, it doesn't report accurately, but I'll go into why it's besides the point. I'm gonna play this video, but before we starting and stopping the videos in PowerPoint is finicky. So once you start, we're gonna try not to stop. So I want to go over some concepts in advance right now. At the top, those two green values represent creating new things. In that case, new integers, new integer arrays. Green is used along the plus sign to represent, the creation of things. Going. This is where you start and go. And the plus sign represent adding something. All of the things representing integers have to do with cubes and are red to really give them a certain idea of, cohesion. You can see this is red and the cube has something to do with integers. Big visualization of what's going on. I use orange and rectangular prism for double values. On the shelf, which where you get things from, you can see that these are values and not. That's like these are values that go. These are data, not necessarily variables holding data, because they don't have names and assignments. As opposed to this array over here, which is name and assignment addition to data inside. Without further ado, I'm just gonna start this, and so you can see. Don't mind the man in the background. You can see right now. Let's see. You can see I'm just gonna narrow what I'm doing. You can see I've dragged the variables update on the display. Now I'm going to cast 2.3 as an int. It becomes 2. You see what has changed. Now I'm going to make a new int. Onto assign value. You see that all updated over there. And we're also going to show off creating an array, which works a little bit differently than creating integers. You saw you just touched the circle. And now we're going to show you create an array. Again, I'm casting this 2.3 to a 2, and I'm giving this value as an input to array to show you. Now it's an array of 2. If you're putting a 5 in an array of 5, we're going to assign this to a value. It's going to update. It's going to be recognized by the display. See, fascinating. So for improvements, more data types have models. Like there are models for, as you can see, you've already seen a little bit of double with its values, but also for Boolean and for strings. The reason they won't show off main is because implementation is complete, and also because they'd be redundant. Data ports aren't complete. They're still worth showing off in the current form because it's the idea that you can look to what you do and say, oh, new code will show up. This is the code corresponding with my action. That makes sense. Because sometimes, it's good to be able to see, like, this code, I can correspond it with a visual in my head because I've already gone through this visual. And other improvements, one thing of note, this is recognized. The current data assignment model is a bit finicky because it's these pre-built numbers that you have to drag and you eventually run out of. And work on implementations for NumPad. Getting this working has been an actual surprising difficulty for many reasons, but the current way of inputting the data is a bit clumsy with it. I don't think that this counts the idea of doing this type of thing in augmented reality itself. That's all the time I have. I hope you enjoyed. I hope you thought this was interesting. Feel free to ask me questions on Blackboard, and What else can I bid you adieu?